In this problem, we have a paper cup in the shape of a cone that has a diameter of 3 inches and a height of 4 inches. The cup is full of water, but there is a leak at the bottom, right here. The cup leaks water at a rate of 2 cubic inches per minute. So dV dt equals -2 inches cubed per minute. We want to know how fast the water level is dropping at the instant when the height of the water is 3 inches. So we want dH dt when the height equals 3 inches. Because this triangle here and this triangle here are similar triangles, we can say that R over R over 3/2 inches equals H over 4 inches. By cross multiplying, we know that R is equal to 3/8 H. The generic formula for the volume of a cone is V equal to pi over 3 R squared times H. Because we know what R is in relation to H, we can see that V equals pi over 3 times 3/8 H squared times H. Simplified, this is V equals 3 pi over 64 H cubed. Now if we take the derivative of the volume formula, so that would be d dt of V is equal to d dt of 3 pi over 64 times H cubed. dV dt would equal 9 pi over 64 H squared times dH dt. Now we want to solve for dH dt. So we can divide by 9 pi over 64 H squared from both sides. Which leaves us with dH dt equal to dV dt over 9 pi over 64 times H squared. Because you want to know how fast the height is changing at H equals 3, we want to solve dH dt at H equals 3 inches. So we want dH dt at H equals 3 inches. In other words, this would be dV dt over 9 pi over 64 times H squared at H equals 3 inches. We want to know the rate at which the volume is changing, or we know the rate at which the volume is changing here, or we know it here at -2, and that H equals 3, we can write this equal to -2 inches cubed per minute over 9 pi over 64 times 3 squared inches squared. Simplify this, and it's equal to negative 128 over 81 pi inches over minutes. So we have found that at the height of 3, the water level in the cup is dropping at a rate of negative 128 over 81 pi inches per minute.